Valery Poliyakov is a Russian cosmonaut who holds the world record for the longest single spaceflight in history. He spent 437 days, 17 hours, and 58 minutes in space, as part of the Mir EO-15 mission. The Mir EO-15 mission was launched on January 8, 1994, aboard the Soyuz TM-18 spacecraft from the Baikonur Cosmodrome in Kazakhstan. The spacecraft carried 3 crew members: Valery Poliyakov, his fellow Russian cosmonaut Yuri Usachev, and German astronaut Klaus Dietrich Flade. They docked with the Mir space station 2 days later, on January 10. The Mir EO-15 mission had several objectives, including conducting medical and biological experiments to study the effects of long-duration spaceflight on the human body, conducting experiments on the Mir space station's materials and systems to improve its reliability and efficiency, conducting Earth observation experiments to study the planet's atmosphere, geology, and natural resources, conducting joint experiments with astronauts from other countries, including Germany, France, and Canada. Polyakov's role. As a medical doctor, Polyakov's primary role on the mission was to participate in medical and biological experiments to study the effects of long-duration spaceflight on the human body. He was also responsible for maintaining and repairing various systems on the Mir space station, as well as conducting Earth observation experiments. Polyakov's stay on the Mir space station was initially planned for 6 months, but it was later extended to a year due to various political and technical reasons. However, he ended up spending a total of 437 days, 17 hours, and 58 minutes in space, making him the world record holder for the longest on March 22, 1995, aboard the Soyuz TM-21 spacecraft, along with 2 other crew members, Russian cosmonaut Viktor Afanasyev and French astronaut Jean-Pierre Higneray. During his 14-month stay in space, Polyakov orbited the Earth 7,075 times and traveled a total distance of 300 million kilometers. The Mir EO-15 mission, particularly Polyakov's record-breaking stay in space, represented a significant milestone in human spaceflight history. The mission provided invaluable insights into the effects of long-duration spaceflight on the human body and demonstrated the viability of extended stays in space. Polyakov's contribution to the mission cemented his place in history as one of the most accomplished and dedicated cosmonauts of all time. As a medical doctor, Polyakov was heavily involved in conducting medical and biological experiments during his stay on the Mir space station. Some of the experiments he participated in included the impact of microgravity on the human cardiovascular system, the impact of microgravity on the human immune system, the impact of microgravity on bone density and muscle mass, the impact of microgravity on the human vestibular system, which controls balance and spatial orientation. Polyakov also conducted experiments to test the effects of radiation exposure on the human body, as well as experiments on the growth of plants in space. During the Mir EO-15 mission, Polyakov worked with astronauts from several other countries, including Germany, France, and Canada. These collaborations involved conducting joint experiments and sharing scientific data. One notable collaboration was the French Cassiope experiment, which involved studying the upper atmosphere's electrical properties. Polyakov worked closely with French astronaut Jean-Pierre Higneray to conduct several technical issues during the Mir EO-15 mission, which required Polyakov and the other crew members to perform numerous repairs and maintenance tasks. One of the most significant issues was a fire that broke out on the station in February 1994. The crew was able to extinguish the fire quickly, but it caused significant damage to the station's systems. Polyakov played a key role in repairing the damage and ensuring the station remained operational. The Mir EO-15 mission and Polyakov's record-breaking stay in space had a significant impact on human spaceflight history. The data collected during the mission helped to inform future space missions, and Polyakov's endurance and dedication inspired future generations of cosmonauts and astronauts. The mission also demonstrated the potential for long-duration spaceflight and paved the way for the International Space Station, which would be launched just a few years later in 1998. In addition to his scientific achievements, Polyakov also set several personal records during his stay on the Mir space station. These records include the longest single spaceflight by any human being, the longest time in space by a Russian cosmonaut, the longest continuous stay on a space station by any human being. Polyakov's records stood for several years until they were broken by other cosmonauts and astronauts. The Mir EO-15 mission had a significant impact on the development of human space exploration. The data collected during the mission provided valuable insights into the effects of long-duration spaceflight on the human body, which informed future missions and helped to improve astronaut safety. The mission also helped to advance international collaborations in space exploration. The partnerships formed between the Russian, German, French, and Canadian astronauts during the mission paved the way for future collaborations on the International Space Station and other space missions. Demonstrated the potential for long-duration spaceflight and helped to lay the groundwork for future missions to explore deep space, including missions to Mars and beyond. The Mir EO-15 mission, and Valery Polyakov's record-breaking stay in space, represents a significant milestone in human space exploration. The mission's scientific achievements, technical challenges, and personal accomplishments helped to pave the way for future space exploration and inspired future generations of astronauts and cosmonauts. The Mir EO-15 mission was a significant achievement for the Russian space program, which had been facing financial and technical challenges in the years following the collapse of the Soviet Union. The success of the mission demonstrated that Russia still had a strong presence in human spaceflight and could continue to make important contributions to the exploration of space. In addition, Polyakov's record-breaking stay on the Mir space station helped to boost morale among the Russian people, who had been struggling with economic hardship and political instability in the early 1990s. The mission was seen as a symbol of Russian resilience and ingenuity, and it helped to foster a sense of national pride. Polyakov's work on the Mir EO-15 mission had a significant impact on medical research, particularly in the field of space medicine. The data collected during the mission helped to improve our understanding of the effects of microgravity on the human body and informed the development of countermeasures to mitigate these effects. For example, Polyakov's work on the impact of microgravity on the cardiovascular system helped to identify the mechanisms underlying spaceflight-induced orthostatic intolerance, a condition in which astronauts experience dizziness and fainting upon returning to Earth's gravity. This research led to the development of exercise protocols and other interventions to prevent and treat this condition. The Mir EO-15 mission helped to establish a foundation for future space missions, particularly those involving long-duration stays in space. The data collected during the mission provided valuable living and working in space for extended periods. These insights have been incorporated into the design and planning of future missions, including the International Space Station and future deep space exploration missions. In addition, Polyakov's endurance and dedication inspired future generations of astronauts and cosmonauts to push the boundaries of human space exploration.